Good day, everyone. Good day, class. So, padayon sa ato ang discussion. So, we are now on chapter 6 sa ato ang kaninga course. And for this topic, we'll be discussing on direct current circuits. So, specifically centered on circuit analysis. Okay, so actually basic lang yun siya sa circuit analysis. Kato lang mga basic rapod nga calculations involving circuits and how to solve circuits, determining its uh, current that passes through each element, determining the voltage, and also determining the power output or power consumption for each circuit. Okay, so let's proceed. So simple circuit or electric circuits may contain the following. So we have batteries, resistors, kanina na-discuss na natin siya, capacitors. In detail, we'll discuss this resistor and how it affects or how it interplays given the given a particular circuit. Okay, let's say na resistor, na capacitor, or a simple lang na ay mga resistors. Okay, and in various combinations na siya. So the same thing is true with capacitor wherein the combination of it is, let's say, the combinations are the following. We have the series combination and the parallel combination. Mao po na diri sa resistor. Okay? So for some circuits, analysis may consist of combining resistors, as I said kanina, na ato'y series and parallel. So those two are very easy to deal with. But there are later on there will be circuits nga mag-involve siya og complicated, medyo complicated na siya nga assembly. So medyo complicated na siya kapag ka-arrange ba. Because when you look at any electronic device or gadgets, the arrangement of the electric circuit elements that are found there may not be as simple as series and parallel, okay? Because mag-require naman na siya of sophisticated nga assembly and combinations, and solving it using our previous knowledge that we had about series and parallel combination will not suffice. So in a more complicated circuits, Kirchhoff's rules may be of good use, okay, may be used for analysis, and these rules are actually based on conservation of energy and conservation of electric charge. So we should keep this in mind. So conservation of energy and the conservation of electric charge for isolated systems. So circuits may involve direct current or alternating. Okay, we have kadungog na masuta na no. The very familiar. We always hear this one. The terms we have the DC for direct current and AC for the alternating current. For the DC, it is always found in batteries. For example, your cell phones. It could be your flashlight. So that's a DC operated. And the AC, these are your appliances. Anything imong i-connect sa socket, sa wall socket in your house of let's say 220 volts na siya typically, some are 110 volts. So expect that those are coming from a electric company source, for example, Veco, okay? And they supply uh, they supply what they call this a potential difference of uh, alternating ang iyahang direction, okay? Or ang iyang value. That's why you have alternating current. More on that later. So for this chapter, we're going to analyze circuits with multiple resistors arranged in series and parallel combinations. Then later on, we will uh, analyze circuits which are in which series and parallel combinations will not be applicable anymore. It will not suffice. So we need level up po na ato ang tool nga gamiton. So we'll be using the circuit, the Kirchhoff's rules, and also uh, we will I think touch a little bit about the concept of ammeter, voltmeter, ohmmeter, and potentiometer in a circuit. And also, lastly, we will look at how electric power is distributed in our respective homes. Okay, so let's proceed. So talking about direct current, okay, this type of current uh, will be of important concept sa kaning chapter because mostly kaniya to ang gamiton, okay, for a particular circuit, any circuit diagram or circuit nga assembly. So when the current in a circuit has a constant direction, which is opposite sa alternating, alternating is it's not constant, it's changing. Okay, so for direct current, from the word direct, okay, so it's not changing and it's constant in direction. And most of the circuits analyzed in this chapter will be of steady state, okay, with a constant magnitude and direction. So that's why we refer to that collectively as a direct current. Okay, you say a voltage source from a battery. Okay. And because the potential difference between the terminals of a battery is constant, the battery produces a direct current. That's why we have a term which is called as a direct current. And the battery in this case is known as the source of EMF. Okay, EMF, which stands for electromotive force. Okay, now what is this electromotive force? So the electromotive force or epsilon ang iyang uh, symbol for the symbol used in this for our class. So the electromotive force of a battery is the maximum possible voltage that the battery can provide between its terminals. Okay. So typical battery can, let's say triple A battery can pila I forgot ang iyang kuan basta around 1.5 volt ang iyang pwede ma-supply. And we also have katong battery bitaw nga mura siya og battery sa itsura niya sa sakyanan katong medyo lapad. Let's say around 12 volt or 9 volts ang iyang ma-supply ato. Okay? And that's the maximum possible voltage. It can never exceed that. It is always equal to that maximum voltage specification or even lesser than that. Okay? Ang imuha ang ma-provide sa battery. So the EMF supplies energy actually, which is very contrary to the name itself. Okay, it stands for electromotive force, but actually it does not supply a force. So it's an analogy lang, or actually it's vaguely used lang siya nga term. It is termed as electromotive force because it somehow gives the electron some kind of a kick or a force, but in reality there's no force. It's actually just a supply of energy. Okay, and once you have your battery wherein ma-set up ang iyang negative and positive and negative terminal, this is high potential and this is low potential. And this is the very reason why your particles will move because of the presence of the set up electric field. Okay. So in this sense, the particle can really experience some kind of a force. For example, an electron, it will tend to move this way, okay, opposite to the direction of the electric field. But for the vacancies or holes, it will move this way, okay, for the positive. So the battery will normally be the source of energy in the circuit. With the presence of the battery, you will have a current, a moving charge. And if you remove the battery, you you definitely or technically stop the motion, okay, because there's no energy supplied. Wala na motion sa imong charge, sa imong charges, so there's no current. So the positive terminal of the battery, as I've said, is at a higher potential than the negative terminal. That's why you have a net movement. You have a movement of positive charge. In this case, a positive charge ang ato ang gitanaw nga nag-move or that causes the current. Also, in all of our examples later on, especially in the calculation of our electric circuit, we will consider the wires to have no resistance. Okay? Because in reality, ang wire itself is a resistor. Okay? Not siya resistance. But to make things simple, we'll just have to ignore that there is a resistance. So, wala lang resistance lang sa ang wire. Except for the resistor itself and, let's say, load, nakaibutang ang load, na siya resistance. But for the wire itself, we will consider it as a having no resistance to keep things simple for now. Okay. So in a battery, inside a battery, there is what we call an internal battery resistance. That's why I've said kanina nga the specification sa battery, let's say 1.5 volt ang siya nga battery, that's the maximum voltage na iyang mapaprovide, maximum possible voltage niya. Okay? And di siya pwede ma-exceed because in reality, naaman siya internal resistance. Okay? As shown in this figure, kani. So the battery itself, kani, na siya internal resistance and that lessens the amount or the maximum possible voltage that the battery can provide because of this. But ideally, if you want an ideal battery, so zero ni siya ang imuhang resistance. But in reality, okay, so in reality, resistance or internal resistance cannot be neglected kay naagi na siya. So you cannot get away with it. Unless otherwise, for a particular example sa circuit, kung gimension sa problem na ma-ignore lang sa ang internal resistance, then you can do so. Okay? But in practical terms, there is always what we call an internal resistance. Okay? So if the internal, as I've said kanina, if the internal resistance is zero, so the terminal voltage equals the EMF. So this is the EMF. Okay? If the internal resistance of the battery is zero, so if this is zero, so ma-neglect nimo siya, so the voltage sa battery is equal to the EMF, which is epsilon. And the internal resistance R, nasa siya voltage, so this one. And so the overall voltage of the battery is we have the electromotive force minus, kaya minusan man siya because of this internal resistance, minus the current that passes through that circuit and the resistance katong unsay given ani nga depende kung unsay internal resistance niya. So the EMF, by the way, is like an open circuit voltage. Let's take a look at this. Open circuit. If wala na siya, so there's no current flowing. But if connected na siya, then there is now a current flowing, continuous. Okay? And the actual potential difference between the terminals of the battery depends on the current of the circuit. Okay? So later on, we will be solving this type of circuit, simple circuit na ni siya, and one loop lang siya. So the current flowing all throughout the circuit is one and the same. So kung unsa ang current diri, mao pod ang current diha. Okay? Mao pod ang current nga mo flow din. Okay? So that's the anatomy sa imuhang battery. So there's what we call an internal resistance. So if you take a look at this graph, kani siya nga graph. Okay? It actually draws the voltage and ang distance, which is for example from A to B. So this is from A to B. Okay. So from A to B, from 0 to A, let's say from 0 to A, and then from A to B, nisaka din ang iyang this one because that's the potential, okay? The electromotive force of that battery, okay? From B to C, the same lang. And then the moment it passes through here sa kaning internal resistance, okay, mo pass through siya diha. So the metabuan na is there is what we call a potential difference, okay? So mo slide down siya And that difference is given by IR. That's the potential difference, tara, IR. And then going back sa kani, so you have, slide down na po siya from from E to F. Okay, from E to F, this one, from E to F. So slide down siya because there is a potential difference given by this IR. Okay. I hope that's clear. Now that there's what we call also the load resistance. So in a terminal voltage, so if you have a terminal voltage, a battery in this case, that also equals the, so if you have a, so this is a terminal voltage, so this is the, yeah, terminal voltage. This is also equals the voltage across the load. You see, for example, this is the load. Okay, ang load resistance is just the resistor, external resistor, okay, or external resistance. So kung unsa, this is same series naman ni siya, kung unsa ang imuhang voltage diri, that would also be the same voltage ang ana. Okay? Kay isa naman ang imong element for this case, right? Okay. Later on, we'll have examples para ma-clarify na siya. Okay? So in this case, this is the load resistance. And it has a resistance big R, okay, which is, lahi na siya sa katong, this is internal resistance, right? Small r. So the resistances represents loads, kani siya. It could be magdugang ka diri another load, let's say R prime, that's another resistance load. So ang resistance load, it could be any device na imong i-connect. Could be a light bulb. It could be, let's say, if you have a one complete circuit, you have a rice cooker. Ang rice cooker, it will act like a load resistance. Okay, if you have your hair blower, hair dryer, or could be your iron, it could be anything. So variable na siya load resistance. So each device or gadget or equipment, it corresponds to a particular resistance, and that's what we call a load resistance. Okay. Then also in electric circuits, we're often interested in looking at the rate at which energy is delivered. Okay? Energy at the rate at which it is delivered. So power is rate of energy delivered. So we have rate and we have energy. So when we talk about energy, that's in terms of joules, right? And when we say rate, there is something that change. Okay, we say rate of let's say sa inyong mechanics, you have the rate of change, which is the rate of change sa inyong distance over time. So we have velocity or speed. Power is the same. Ang imong nag-change lang is ang energy. So we have change of energy with respect to time. So joules per second. Joule is a unit of energy. And this joule per second is termed as watts. Okay? And watts or watt is the unit of power. Okay? So muna siya ang unit of power. Joules per second or watts. And symbolically, we have this equation also, which is power is just current times the potential difference or current times the EMF. Okay? For example, EMF walay, let's say consider nimo imong battery nga walay internal resistance. Okay, thus we have an EMF. So the power delivered to the external resistor is actually equal to this. Okay, because P equals IV And since V equals IR, di ba, sa atong Ohm's law, so we can substitute I times R. That's why we have I squared R. So that's the equation also for power. In terms of current, okay? So if we look back sa kani, right? Oops. So if we look back here sa kaninga circuit, we can say that for this circuit element, the power delivered by the battery onto this, because ang battery man ang mag-provide og energy. Now, this internal resistance will receive an energy input from the battery. Okay? So, ang battery mag-supply og energy. So, mag-deliver siya og power sa kaninga circuit. So, the power is given by I squared R. While for this case, the power is I squared big R. Okay? And the total power is just I squared R plus I squared small r. Okay? So that's the total power uh, delivered onto the circuit. Okay? Excuse me. So few reminders. The battery again is a supply of constant EMF. Okay? And that the battery does not supply a constant current, since the current in the circuit depends on the resistance. So depending on the resistance, vary man ang imong current sa imong circuit, but the total current is the same. And the battery does not supply a constant terminal voltage. Okay? Lito, in the long run, mag-deplete man ang energy sa imong battery, and then otherwise, if ang imong battery is rechargeable, so imo na po siyang i-recharge, and then that would mean mo supply kag energy sa battery. Okay. Then we go into the resistors in different setup. So resistors can be arranged in a series combination sa circuit or parallel, or it could be much complicated than that. Okay? Dili siya mo follow og series and parallel combination. Okay? So let's start with resistors in series. Okay. So if you have two or more resistors which are connected end to end, they are said to be in series. So if you have resistor 1 connected end to end, then this is resistor 2. Okay? So these resistors are said to be in a series combination. Now for a series combination of resistors, the currents are the same. So if you have a current going here, this is, say, I1 and this is I2. Since series man siya, so I1 must be equal to I2. So I1 is just equal to I2. It's just equal to I. Okay, that's for the series combination. So the currents are the same in all resistors, because the amount of charge that passes through one resistor must also pass through all other resistors. So wala may mabilin diha. Okay, kung unsa to ang milabay nga mga charges sa resistor R1, those are also the same charges that will pass through R2 and R3 and so on if you have extended number of resistors in your circuit. Okay, and the potential difference will be divided among the resistors for a series. Okay, so if you have a total voltage V, the 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 voltage potential across each resistor will be divided. So you have V1, you have V2 here, and in such a way that the total voltage, say total, is just V1 plus V2. Okay? So mo ni ang key concept sa series connection. The current is the same sa imong series, sa imong circuit, while the voltage will be summed or mo add up siya. Okay? Mo vary ang imong voltage because of different resistance. Dalang kung pareha ang resistance, pareha ang current, so that definitely pareha ang imong voltage reading for each circuit element. But for the case nga dili pareha, so the total voltage should be the sum of individual voltages. This is what I've said kaganina. So we have this one, and the potentials add up. Okay, and since, take a look at this, since I1 and I2 kay the same raman na, right? So we have V1 plus V2. V1 is just IR1, the same naman ang I sa both. We have IR2, so i-combine mo ang common which is I. So you have IR1 plus R2. So technically, kani siya, so if you have V total, it's just I R total. And so your R total is just R1 plus R2 plus R3 and so on, right? Kasi N ka resistors. So that's the idea. Sa imuhang combining resistance or resistors in series combination. So ipang add up lang nimo siya. So if you have this, so this can be simplified kani imuhang circuit, ma-add man ni siya R1 and R2. So this circuit becomes like this. So one, ano na lang siya, equivalent. So this is your R total, which is just R1 plus R2. Okay? So this is what I've said again, or the R equivalent, that would be the sum of all individual resistances. And you have R sub n if you have n number of resistors for that matter. So the equivalent resistance of a series combination of a resistors is the algebraic sum of the individual resistances, kanina equation. And it is always greater than any individual resistance. Of course, i-add up mo siya. So the R equivalent is always greater than R1, always greater than R2, and so on. So if one device in the series circuit creates an open circuit, meaning if kani siya mabusted, so wala na siya diha. The rest kay mabusted po, di na siya musiga. So for example, kani. So this is bulb. So bulb ni siya, ang R1 and R2. If R1 gets busted or destroyed, mahitabo is this will create an open circuit. No current flows in the entire circuit na. So dili na po na siya musiga. Okay? That's the downside sa series circuit. If maguba ang isa, guba tanan. So if dili mo siga ang usa, di mo siga ang tanan. Kung ma-absent ang usa, absent tanan. So it's like that. Okay? So magkahiusa na sila. So take a look at this. All three representations are equivalent. Okay? So if we have this one, R1 and R2. Okay, this is your a pictorial representation of two resistors connected in a series battery. You have bulb 1 and bulb 2, and these bulbs can be represented by resistors, resistor 1, resistor 2. Since series connection man siya, this can be added. Okay, so R1 plus R2 lang siya. So we have this equivalent resistance. So some circuit notes, a local change in one part of the circuit may result in a global change throughout the circuit. Okay, for example, changing one resistor will affect the currents and voltages in all other resistors and the terminal voltage of the battery because, as I've said, that's the consequence of having your circuit arranged in a series connection. Okay, so in the series circuit, there is one path for the current to take. And later on, discussed the parallel. For parallel, multiple ang iyang paths nga i-take compared to series. Okay? So let's talk about resistors in parallel. So the potential difference across each resistor sa parallel is the same because each is connected directly across the battery terminals. For example, this one. So if you have a total current, ang current is ma-divided siya into this and into this. Okay? And the potential difference will be the same dinha. Unlike sa katong series nga ma-add up siya, for the parallel combination, okay, for the parallel setup, if this is delta V, then this is also delta V, this is also delta V. Okay, that's why you have this. Uh, so you have this. You have delta V equals delta V1 equals delta V2. And a junction is a point where the current can split. If you take a look at this, is the junction. Okay? Junction. Nag-split siya. Ang I, nahimo siyang I1 o I2. You have I1 and this is I2. Okay? So the current I that enters a junction must equal to the total current leaving that. That's why we have this. Okay? So the total current I is just I1 plus I2. And if you substitute I, which is delta V1 over R1 plus delta V2 over R2, okay, ito is what? Okay, that's delta V2 over R2. And since delta V1 and delta V2 kay equivalent man siya, so we have delta V. So that's why we have R1 plus 1 over R2. So this is like delta V R equivalent, okay, where your R equivalent for the parallel circuit combination or connection is 1. Okay, let me see. Sorry about that. It's like this one. Okay, 1 over R equivalent. So 1 over R equivalent is just 1 over R1 plus 1 over R2. If you have many resistors connected, then you have this. Okay, so that's why we have this equation. So ang imuha lang timan-an basta series gani, R equivalent is just R1 plus R2. Pero kung parallel lang gani, mo na siya ang gamiton. Okay? Because of this concept that we had, and we discussed about this one equal ang voltage and then the current is just the sum. And the inverse of the equivalent resistance of two or more resistors connected in parallel is the algebraic sum of the inverses of the individual resistance. So let's say you have kani siya, duha naman ni siya no, ka resistance. So that would be 1 over R equivalent, that is 1 over R1 plus 1 over R2. So imuha naman ang i-add. So we have R1, R2. Common niya kay R1 and R2. So divide mo siya, we have R2 plus R1. Okay? And to get the inverse man siya, so to get the R equivalent, so that is equal to R1, R2 over R1 plus R2. Okay? The one na imuhang equivalent resistance. So in parallel, each device operates independently of the other so that if one is switched off, the others remain on. Mo na siya nakanay sa parallel. So if this one is busted, although wala na siya nagsiga, but since ang current nimo is wala na mo flow nga current diha, right? Wala na mo flow nga current, but tinhina pa man gihapon. So musiga gihapon ni siya, okay? Siga gihapon na siya. Or the other way around, if ang R1 ang busted, R2 will still keep shining. So in parallel, each device operates independently of the others. Balik ko gani. Okay. So in parallel, all of the devices operate on the same voltage and the current takes all the path. Okay? So tanan kung pila na siya ka division diha, kasi kung 5 na kabuok parallel connections, the same na siya voltage tanan and each will have its own current. Okay? And the current takes all the path, so the lower resistance will have a higher currents kay mura man na siya og kung kumbaga na ay murag mind of its own ang current ba. If gamay gani ang resistance didto, of course daghan pud ang moagi didto nga current. So it's like that. Kung baga masayon agian, dito tatanan daghan kay mangagi didto. So inana na pud ang analogy for this case. Less lower resistance, higher ang iyang current. So for parallel connection, the same ang voltage but pag-differ ang iyang current, ma-divide man siya. And kung usa kadako ang current nga moagi sa each resistor, depende na siya kung usa ka gamay o usa kadako ang resistance. So that is why household circuits are wired in parallel connection so that electrical devices can be accommodated. Okay? So magsaksa ka og appliances, bisa pagpila na siya ka appliances, the same magyapon na yung voltage nga ma-receive, right? It's 220. Okay? If series pa na siya, so ma-divide ang imuhang voltage. So bisan pila pa ka appliances na imong ikabit sa wall socket sa imong balay, those will operate at the same voltage. Say, let's say 220. And even if ang imong refrigerator is mabusted, maguba, wonder gihapon ang imuhang electric fan, ang imuhang stove or electric stove or any gadget nga imong gisaksak because they are arranged or connected in parallel. Okay, let's consider an example. Take a look at this. So this is the example. So compute the equivalent resistance of the network in this figure. So you have an EMF source of 18 volt and simple lang ang internal resistance is at 0. So the voltage is equal to EMF and it has 3 resistors arranged in this one is parallel and in series sa 4 ohm. Okay, this is ohm. And we are asked to find the equivalent resistance, okay, for this example. And then later on, we'll be able to calculate the current that passes through to each resistor and also the voltage reading for each resistor. Okay. So in doing this, we'll just have to simplify first the circuit. So take a look at this figure. From figure A, nahimo siyang figure B, then nahimo siyang figure C. So iharang simplify. First is you need to combine first this kaning duha kaning parallel. Ang parallel imo siyang usahon. So that would be 1 over R equivalent. That is 1 over 3 plus 1 over 6. So this would be, common nila is 6, right? That would be 2 plus 1. So this is 3 over 6. So 1 over R equivalent is just 1/2. Okay? And so R equivalent is just 2. Okay? 2 ohm. That's why naako ani. Nemo siyang 2 ohms, right? Sa figure B. And then this 2 ohm and the 4 ohm here, okay, in series connection, so ma-add up na siya. So we will have R equivalent here equals 4 plus 2, and that is 6, okay, 6 ohm. That's why 6 ohm is here din ha. And so if you have 6 ohm here, so we can calculate the current that passes through sa kaning circuit and also the voltage. But since series man na siya, if we just change the color, where's black? Blue, red. So since series, okay, since series man siya, so 18 volt. So this is also 18 volts po na diha. Right? Okay, series man siya. And isa naman siya ka element. And the current that passes through here is just, iwala ba ng I equals V over R, right? So ang voltage ana is 18 divided by 6 ohm. So the current is 3 ampere. So the current that flows here, let's say in that direction, it's 3 ampere. Okay? So 3 ampere ang ihang current. And then pabalit okay, from figure C to figure B na po. Okay, so since 6 ohm man siya and it has 3 ampere, okay, and if imo siyang ibuwag ana, let's say from 6 na mo siyang 4 ug 2, right? Since series man siya, so you recall the series connection, the same ang ihang current. Okay, nga mo pass through sa kanang resistor because it's series. So this is 3 ampere na siya. Diri pod is 3 ampere. So you have 3 ampere here. I have the current and the resistance. So you can calculate the voltage that passes through sa kaning 4 ohm and 2 ohm. Okay. So voltage is just current times resistance. So we have 3 amp times 4 amp. So we have 12 volts here. Sa kanya, we have 6 volts. Okay, so the total should be 18. So this is the total, 18, which is correct. So makes sense here. And then later on, after that, from figure B, ato na sa figure C. So inana ang style niya ha. From figure A to figure C, imong simplify ang circuit to just one equivalent resistance. And once you get that, pabalik na pud ka, i-deduce na pud nimo kung unsa ang mga current and voltage niya for each. Okay? So pag-abot din take a look nga parallel man na siya, no? So sa parallel, if i-recall nimo ang ato ang lesson o katong topic, concept on parallel circuit, the same ang iyahang voltage. Okay? So for the 2 ohm, composed na siya of 6 ohm and 3 ohm parallel. 6 volts man na siya, so this will also be 6 volts. Okay? So 6 volts ni siya, 6 volts po na siya. Okay? And the current that passes through will be different na. We have 6 ohm and 6 volts. So ang current niya is I equals V over R. Muna siyang gamitin na formula. So in this case, 6 volt over 6R, 6 ohm, which is the resistance. So this is 1 ampere. Okay? Muna ang current niya. 1 amp. Sa obos, we have 6 divided by 3. So we have 2 ampere. So you have 1 amp plus 2 amp, it will give you 3, which is mo na siya ang total, right? This is 3 amp total. And for this case, sa kaning 4, right? 3 amp man di ba? The same, katang 3 amp. So ang ihang voltage ani niya is just 12, which is mao man ni ganina kani. This is 12 volt. So based on this example, we actually solve it by just using the series and parallel connection sa imong circuit. Okay? So ang simple ang imong buhaton if faced with this type of problem, first is to simplify the circuit into one equivalent resistance. And once you have the equivalent resistance, you can solve for the current and the voltage sa kada ang particular na circuit element, and then go back ka sa imong original circuit to get the current and the resistance for each individual resistors. Okay? So kan the same man siya, actually similar siya atong previous na atong example ganina. So we have this connection, so unahon nimo ni siya sumpay kani, and then once masumpay na siya, you have 2 ohm, then isumpay na siya, you have 14, right? Okay, so you have this. Okay, we'll have, let's consider another example. Napay isa ka example, this. Okay. So you have 2 identical light bulbs are to be connected to a source of 8 volts and negligible internal resistance. Each light bulb has a resistance of R equals 2 ohm. So find the current through each bulb, the potential difference across each bulb, and the power delivered to each bulb and to the entire network if the bulbs are connected in series, in parallel. And suppose, letter C, suppose one of the bulbs burns out, that is, its filament breaks and the current can no longer flow through it. What happens to the other bulb in the series case and in the parallel case? Okay, so let's draw the diagram here. So this is the connection. Okay, for letter A, it's arranged in series. So each bulb is of 2 ohms ang iyang resistance. Okay, for the figure B, this is parallel. So what happens to the power delivered sa kaninga case if series and power delivered if uh, parallel ang iyang uh, connection. Okay. So for question A, that is, what is the power delivered to each bulb to the entire network if in series siya? Okay. So we can get actually the R equivalent for that case. So the R equivalent for letter A ha. So we have 2 plus 2 series pa na siya. So we have 4 ohm. Okay. And from this given, natay R equivalent, tapos ang atong voltage given one which is 8 volt, right? So we can get the current. So that's V over R. Okay, so which is 8 divided by 4. So this is 2 amp. Okay, so 2 ampere ang imuhang equivalent. Okay, current. So sa imong circuit, since series man na siya, so kani siya, this must be 2 ampere na siya. So kanipod 2 ampere po na siya. So from each of these resistor which has a resistance 2 ohms and the same po sila og current 2 amp, so the power delivered through each resistor is given by pwede kani nga formula I squared over R. Okay, so we have 2 squared times ang resistance nimo is the same raman which is 2. Okay, so this is 4 times 2, we have 8. Okay, 8 watts for each na siya, for each resistor. Kaya the same man sila og specification, the same resistance and the same current that flows through it. Or you can use this formula, katong V squared over R, right? So where did I get this formula? I is, you can see here, I is just V over R. So you have V squared over R squared. Then makancel lang isa ka R ani. So you have V squared over R. Okay, so either way, the same as sila makuha. So this is uh, the volt for each resistor. Okay, so ang voltage ani, this is series man na siya, so ma-divide ang imong voltage. So VIR, so this is 4 volt, right? This is 4 volt po. Total is 8 volt. So this is 4 volt over 2 over 2. So we have 16 over 2. So we have 8 watts. Okay, so the same again as siya. So that would be the power output delivered sa series, okay? Now for the parallel, so lahi na yung scenario. For the parallel, let's take a look at the R equivalent. So this is for A. For B, so ang R equivalent niya is this. 1 over R equivalent, that would be 1 half plus 1 half, which is 1, right? And if kaon mo ang reciprocal, R equivalent is just 1 ohm. Okay? So that's 1 ohm. And then we can calculate for the current. Okay? So if you have, so kano siya mahimo ni siyang this is 1 ohm, right? And this is 8 volt. So ang current na ni-flow dinhi, that would be, of course, current is V over R. That would be 8 over 1. So that would be 8 ampere. So this is 8 ampere. Okay? And since ano man na siya, okay. Ang voltage po ano niya, of course, it's 8 volts. Right? 8 volts. So this must be 8 volt diha. 8 volt po. Okay, parallel man na. However, the current, so ma-divide siya. So ang current nga moagi dinhi, that would be V over R. So that would be 8 volt divided by 2. That would be 4 amp. Right? The report is 4 amp pod. Okay, ang total niya is 8. And the power delivered for each, okay, so you have I squared R, and the current that passes through each resistor is just 4 squared times resistance is 2. So we have 16 times 2, that would be 32 watts. Okay? For each na siya, for each. Okay. So if you compare this sa katong letters, if you compare nimo ang power output, take a look. So you have 8 and 32. So if you have a bulb nga ang isa kay 8 watt tapos ang isa ka bulb is 32 watt, of course, will differ ang ilahang brightness, right? Because that's why mo kung mapalit ka og kanang bulb, di ba? If gusto ka gahayag nga bulb, dapat ang ihang wattage is mas dako. Mas dako ang ihang wattage, mas hayag siya. Now, to if ang purpose nimo is to get is to have is to produce a maximum amount of light from each bulb, then the parallel arrangement is superior. Okay? Mas okay ang imuhang parallel nga circuit nga arrangement. Okay? And take note na times 4, if you have 8 watt and 32 watts, so 4 times as much ang imuhang maproduce nga power output if you arrange it in a parallel combination. And also, if one gets busted sa kaning parallel, the same output gihapon sa power ang imuhang makuha for for this particular bulb, even if mo die out na imuhang isa ka resistor, because it is arranged in parallel, unlike sa series nga wag madaot ang usa, daot mo ng uban. Okay, so we have that's a merit actually sa parallel nga circuit. More power ang yung output, at the same time the if one of the bulbs fails, the other bulbs are unaffected. So that's the principle of also of our household wirings. That's why it is arranged uh, in parallel connection. Okay. Okay. So next atong i-discuss is those circuits involving ang iyang connections is not anymore solvable by simple series and parallel combination. Okay. So what I'm talking about is this, the Kirchhoff's. So magamit ang Kirchhoff's rules. And this Kirchhoff's rules was developed by a German physicist named Gustav Kirchhoff. Also, Gustav Kirchhoff worked along with Bunsen, and together they invented the spectroscope and founded the science of spectroscopy. They also discovered the elements cesium and rubidium and invented the astronomical spectroscopy. Grabe ni silang power of 2. Sana all. Okay, going back to Kirchhoff's. So there are ways in which resistors can be connected so that the circuit's form cannot be reduced into a single equivalent resistor. That's why mogamit na ta og Kirchhoff kay di na siya applicable ang katong series and parallel combination. So we can use the Kirchhoff's rule instead. And duha ka rules ang mo atong gamiton for this Kirchhoff's rules. We have the junction rule and the loop rule. Okay, talking about the junction rule. So the junction rule states that the sum of the currents at any junction must be equal to 0. Okay, so currents directed into the junction entered into the equation as positive I and leaving can negative I, and that is a statement of a conservation of charge. So for example, you have a junction here, na ako'y wire diha, na ako'y wire, and this is wire. So if I have a charge coming in, current I, so kung unsa ang mosulod, mo po na ang magawas, ma-divide siya din ha, right? So we have, let's say this is I1 and this is I2. So in that case, the total I must equal to the sum, right? Or I1 plus I2 plus I equals 0. Okay, the total current nga ni-enter ani. And since ang tanan pasulod kay positive, so this is positive ang I, so ako na i-rewrite. I-rewrite this one. Let us use the convention. So ang I is pasulod, so that would be positive. And then pagawas ang I1 ug I2, so that would be minus I1 minus I2 equals 0. Okay? That's why mo na siya nga equation. Okay? Summation, gi-add nimo tanan contribution. So we have this, okay? So you have I1 entering, then you have I2 and I3 leaving. So that's why you have I1 entering positive, I2 and I3 leaving, so negative, and equated to 0 na siya. Meaning walay na stack up sa junction. Tanan kay ni leave. Okay? Tanan ni flow siya ba. So example lang ni iyahang analogy is this. So the amount of water flowing out of the branches on the right must equal to the amount flowing into the single branch on the left. Okay? Kung unsa ang what flows in must flows out. Okay? Muna siya diha. Then we also have the Kirchhoff's loop rule. So Kirchhoff's loop rule states that the sum of the potential differences across all elements around any closed circuit loop must be 0. Okay? So isum nimo ang tanan voltages. Meaning katong kada circuit element na siya equivalent voltage. Tapos i-add nimo tanan kung pila to ka circuit element, the total voltage should be equal to 0. And that is a statement of conservation of energy. Okay? So energy is conserved. It is not destroyed but can transform to other forms. Okay? So this is for the loop rule. Okay, later on makatatag example kaning loop rule kaning natay ginatawag na traveling around the loop, okay, from A to B. So if this is your direction sa current, okay? So in A, so the resistor is traversed in the direction of the current. Let's say this is the current tapos ang loop nimo is diha pod padulong. Okay? So ang convention ana niya is negative ang iyahang what they call this, yung sign sa imong voltage, so negative IR. And if the opposite ang iyang direction sa current, this is the direction sa loop, okay? So if opposite, then positive ang iyang sign convention. Or inanay po na siya, if you have a circuit element nga battery, so this is a circuit element niya kay resistor. So for a circuit element nga battery, if diri imong loop, so that would be positive na siya. Okay, ang iyang sign. So that would be positive epsilon. This is the loop. So this would be negative. Okay, from positive to negative mo na siya. This one is negative to positive. That's why it's positive, ang sign. Kani is ang loop niya is padulong to the right. From positive to negative. So this is negative epsilon. Ang iyang sign. So we can use the junction rule as often as needed. So as long as each time you write an equation, you include in it a current that has not been used in a previous junction. So as much as possible, gamiton og una ang junction rule. And later on, gamiton nimo ang loop rule. It can be used as often as needed, so long as a new circuit element, resistor or battery, or a new current appears in each new equation. Okay? Maghatag tag example ani para mas masabtan. Okay, let's take a look at this example. So take a look at the figure in figure A. Figure A. So these two networks, A and B, so it cannot be reduced anymore to a simple or equivalent series parallel combination of resistors, right? Wala na siya way nga gamit nimo ang series and parallel concept. Okay? So thus, the Kirchhoff's rules on junction and loop rule will prove useful and applicable to this type of problems. So few tips and reminders in using Kirchhoff's rules. First, as I said kanina, igamitin nimo ang junction rule as needed, and then later on, magamit din sa loop rule. So in this case, sa figure A, you have how many junction? You have two junction. You have junction A and junction B. Because for it to be called a junction, dapat na ay tulo ka branches. Okay? That's why you have at least three. So sa junction A na ako'y three ka branches, right? Also for the B. C and D are not junction because duha lang ang iyahang branches. Okay? And for this type of circuit also, na siya tulo ka loop. Okay? You can have loop 1, which is the entire sa circuit. Okay? So sa loop 1, ang maagian niya nga mga circuit element, so ang direction is counterclockwise. So ang maagian niya nga circuit element is resistance R1, the battery, and this resistance R. So ang sign niya is later on mag-decide ta kay wala pa to na set asa ang iyang current padulong. Anyway, for loop 2, mo siya sa sulod. So ang iyang maagian nga circuit element, you have R1, the battery 2, and the R2. For the loop 3 as well, we have R2, the battery 2, and the big R resistance. For letter B, you have how many junctions? So you actually have 1, 2, 3, 4. Okay, 4 junctions. And you have how many loops? You have 4 loops. Okay, you have ang first na loop is the outer. Ang mga succeeding loops is sa inner na siya. We have the second loop, the third loop here, and the fourth loop. So these junctions and the loops will be used para maka-create og equations, and then those equations atong gamiton para ma-solve na to ang current nga ni pass through and also the equivalent voltages. Okay? Consider that example. Okay? So consider the circuit in this figure on the left. It contains 2 batteries, each with an EMF and internal resistance, and 2 resistors. For letter A, you find the current in the circuit, the potential difference, AV, and also the power output of the EMF of each battery. Okay? So to solve this, first we need to assume the direction of the current in the loop. So in this case, nalaman diri ang iyang direction sa current. Atong gi-assume, actually, pwede lagi bisan asa ang direction sa current. Could be counterclockwise sa kaning case, pwede po ka ma-assume nga counterclockwise. So we'll see it later. Okay, so for this case, counterclockwise ang atong i-assume nga direction sa current. Why? Because of the direction sa imong battery. Okay? Although kani siya paana ang iyang direction ana, but this one has higher potential, okay, or voltage. So we will use this 12 voltage ang iyang direction sa current is from positive to negative. So ana siya counterclockwise. So for letter A, in this example, based on this diagram, the assumed direction of the current is counterclockwise. So using the loop rule, so we can only use loop rule here. Hindi ta kagamit o junction rule. Kaya wala may junction din eh. Okay? And ang unknown naman ani is the current. So we have one unknown. So we technically we only need one equation. Okay? If you have two unknowns, then we need at least two equations. You have three unknowns, three equations, so on. So for the loop rule, okay, gamit ang loop rule, right? So counterclockwise. Start ta sa battery nga 12 volt. And since ang direction niya sa loop is dinhipod, dinhapod ang direction sa loop, and ang direction sa current is that, in this direction, so it's actually positive ang sign, 12 volt. So we have 12 volt. Then agian nato ang kaninga resistor, and ang direction sa current is dira pod, so negative siya ang sign, right? Negative 2 times I. 2 is the resistance. Then minus na pod, kay the same ang direction sa current ang direction sa loop. You have 3I. Then minus 4I. Take note, the same I na siya tanan because this is a series connection. So the same ang iyang current all throughout. And then we go now to the battery. So ang battery is ang loop direction is dinha. So from positive to negative, so this is a negative sign convention. Negative 4. 4 volt na siya. And then minus 7I. Okay? This is equal to 0. Mama na siya ang loop rule, right? The sum of all voltages is equal to 0. So we can solve this equation. We can solve for I. I naman ang unknown ani, the rest kay given. So 12 minus 4, the same man siya mga voltage, right? So we have 8. Oh. Tama ba? Okay, 8. So we have 8 volts minus, pang-add naman siya, 2 minus 3 minus 4 minus 7. So we have 5 minus 4, that's 9. 9 minus 7 minus 16, right? So that would be minus 16 equal 0. So 16I. Okay. So I therefore is just 8 volt divided by 16, which is 0.5 ampere. So that's the current that flows sa imong circuit. Okay? And ang result niya is positive. So ang result sa sign sa imong current is positive. That signifies na sakto atong gi-assume nga direction sa current. Okay? But if you chose nga ang direction sa current is opposite, okay, ang mong gi-assume nga direction sa current is opposite, then you should get an I which is negative 0.5 ampere. Negative, that would mean indicating that the actual current is opposite to this assumption. Okay? Then we can calculate for the voltage AB. Okay, asa man ang AB? Tara, voltage AB. So there are two ways nga makakuha ta sa voltage AB. It could be sa lower right, this one, or the upper left. Okay. So let's start with the lower right. Kani siya. Pila ka ang voltage ana. Okay. So for the voltage AB, using the lower right, so we have this resistor, the battery, and this resistor. And ang current niya is 0.5, diba? So we have 0.5 times 4 ohm. And this is okay, that's way paagi. Yeah, so positive. So this is positive plus 4 volt plus 7 times 0.5. So totaling that one, that will give me 9.5 volt. Okay. Or we can just simply use katong the upper left. Okay. Upper left. So ang magiani mo is dira ka padulong ana. So we have 12 volt minus 0.5 times 2 ohm minus 0.5 times 3 ohm, okay? And then that would still give me 9.5 volts, so the same siya, okay? You can also calculate the power output of the 12 volt battery. Ang question is, the power output sa imuhang 12 volt battery and the power output sa imuhang 4 volt battery, okay? For the power output sa imuhang 12 volt battery, so we have epsilon times I. This is 12 times, and current is 0.5, right? Which is 6 watts. And of course, the power sa imong 4 volt battery, so we have negative 4 volt, kay opposite man siya, if maana ka, right? So this is negative 4 volt times the current, which is 0.5 ampere, that is negative 2 watts. Yang imuhang power delivered, a power sa imuhang 4 volt battery. So the negative sign for the 4 volt battery appears because the current actually runs from the higher potential to the lower potential. Eh? And the negative value of power means that we are storing energy in that battery. Okay, so it's like that battery is being recharged by a 12 volt battery. So in this case, the 12 volt battery provides energy para ma-charge ni ang imuhang 4 volt na battery. Okay, that's pretty amazing. Then we have this example. So this example, I will leave it to you as an exercise. So kamo na yung bahala mo solve ani. So this is actually easier naman na siya to solve. Okay. So in this case, makuha nimo diha nga if you solve it, your current here is kani nga current, which is the unknown. Have to solve it, makuha nimo nga 3 amp na siya. And then the small r, which is this, is given by 2 ohm. Okay? And then the epsilon, which is this, after solving it, makuha nimo is actually negative 5 volt. So sa kanina case, imong equations ang gamiton ani is could be loop rule and also junction rule. Okay? So you should be able to get the following. Okay? So ano lang, try to understand the problem first and then you solve it on your own. Okay? Let's proceed with this one. So all of this, incorporate nimo siya that those connections, series and parallel, and also the Kirchhoff's rules that comprises your household wiring. Okay? Imuhang medyo complicated lang siya, advanced ang imong household wiring, but if you look at the fundamental nga level, it's actually arranged in just a series of combinations, of parallel or any combination or connections. So the utility company distributes electric power to individual homes by a pair of wires. So duha ka wire is a pair of wire. Okay? And each house is connected in parallel with these wires. One wire is the live wire, and the other wire is the neutral wire connected to the ground. So the ground ni mga connection. So you have this. So the potential of the neutral wire is taken to be zero, ang imong ground niya, ground state or ground niya. So this is the live wire, say 120 volt. Sa ito nga case, we have 220 volts. Okay. So in this case, actually the current and voltage in this case are alternating. Okay, so it's not direct current anymore. So alternating siya. Or AC ang tawag. And the potential difference between the live and the neutral wire is about 120 volt in Western countries and 220 in our country setting, Philippines. And then a meter is connected in series. We have meter here. A meter is connected in series with the live wire entering the house, and that will record the household's consumption of electricity. After the meter, it is being split into multiple parallel. That would mean multiple ni mga connections that would correspond to different appliances nga pwede makabit. Okay? So, pwede nimo siya din siya for iron, din siya for washing machine, and so on. And each circuit has its own circuit breaker. So, nasa circuit breaker here. In case lang for emergency or mga accidents, right? So, natay circuit breaker. And for those applications requiring 220 volt, there is a third wire maintained at 120 volt below the neutral wire. Okay? So, as I said ganina, sometimes natay mga accidents nga ma-happen, kabantay mo anang usahay makalitlag paka bitaw o spark ang imuhang something nga na-wire tapos mubutulag galit and mubutol ang imong sa socket. So accidents do happen sometimes, and that's because of short circuits. So you always hear it that short circuit. So you always hear it when something happens in the circuit breaker or a fuse gets busted. So a short circuit occurs when almost zero resistance exists between 2 points at different potentials. So dito siya mo automatic og connect bitaw. So, that's why short circuit siya or the shortcut ang imuhang electric current. So this results in a very large current. So in a household circuit, a circuit breaker will open the circuit in the case of an accidental short circuit, and this prevents any damage. And a person in contact with ground can be electrocuted by touching the live wire. So it's a big no-no. So sometimes na mga accidents yung mahitabo, electric shock can result in fatal burns and even to death. Di ka naman sutag na balitaan mo nga na-aksidente sa live wire, kanang nakahikap sa live wire, patay gina diretso. Gamay ka chance nga mabuhi. Example katong bata nga gibalita sa Jessica Soho na nagkupot siya og ang bata wala bantay nagkupot og tinidor. Tinidor is a very good conductor. Then ihang gipasok sa ang tinidor gipasok niya sa extension wire and then boom, patay ang bata. So accidents do happen, right? And because of large amounts of currents nga ni float sa imong body that would actually kill you. Okay? So electric shock can cause the muscles or vital organs to malfunction, including the heart. So the degree of damage depends on the magnitude of the current, the length of time it acts, the part of the body that touches the live wire, and the part of the body in which the current exists. So these are the various currents and unsay effect na sa person. Okay? If you have 5 milliamp or 10 milliamp or 100 milliamp, mo ni ang iyang mga effects sa imong body, right? So it's actually the current that kills, not the voltage. Okay? So analogy ani niya is if you have a river flowing. So if you have a river nga dili kaayo siya, if you have a river nga steep kaysa nga tanan, right? This is a river. But then ang nagflow nga water niya, ang flow that corresponds to the current, right? Kasi ang nagflow nga water niya is gamay lang jud kay siya. It's like tulo lang bitaw. So it will really not affect you, right? Because gamay raman ang imuhang ang current, gamay ra ang tubig, right? So di kay siya makaunsa sa imuha. Although steep kay siya, meaning dako ang iyang potential difference or voltage. But if you have not so steep, meaning low voltage, but ang iyang volume sa current is daghan kaysa nga tanan, that is enough to drown you, even though dili kay siya na nakadako ang iyang steepness, right? Di kay na nakakuso ang iyang motion, but daghan kay ang volume sa current. So it's actually the amount of current that kills you, okay? The current, not the voltage. That's why naatay kani nga measurement, you have 5 milliamp, 10 milliamp, and then 100 milliamp. Katong sa case sa bata nga nabalita sa Jessica Soho nga around 200 milliamp gito. ang na-receive niya nga dosage or even greater than that. Okay? So in some cases, currents of 1 amp can produce serious burns. Sometimes this can be fatal burns. Okay? No contact with live wires is considered safe whenever the voltage is greater than 24 volt. So na siya dako na side effect. How much more katong 220 volt ang musulod sa imong body. And that's why electrical equipment manufacturers use electrical cords that have a third wire called the ground para mas safe siya. So in this situation shown here, the live wire has come into contact with the drill case. As a result, the person holding the drill acts as a current path to the ground and receives an electric shock if duha lang. But if you have a third wire, a ground wire, the drill case remains at the ground potential and no current exists in the person. So dili siya ma-electrocute kay mo short circuit man siya diri sa ground. Okay? That's why safe na siya. Actually safe gina kana bitong imuhang wire sa imong laptop nga o imong charger di ba na siya tulo ka prong. The third prong corresponds to the kuha na siya ground para mas safe ka. Pero sometimes di ba at wala siya ginatangtang ang ikatulo. But it's actually better nga naana siyang ikatulo nga prong yun for safety purposes. Okay? So that would be all for this topic. I hope you've learned something. And we are now down to our last 3 chapters na lang. So hapit na mahuman ang kaninga semester. So kapit lang, laban. And if you have questions, feel free to ask me over this video, comment down below, or you can message me sa Facebook if you have something and you need clarification. Okay? So that will be all. Thank you. Stay safe and God bless.